Okay, our last presentation is titled Mycoplasma hyosynoviae, Serum Profiles and Other Ongoing Research. And for this presentation, we will have two presenters. The first is Haley Schwecke. She is a second-year master's student at the University of Minnesota studying Mycoplasma hyosynoviae under Dr. Maria Peters. She grew up in rural Minnesota on a commercial and show pig operation where she gained her passion for the swine industry. And Dr. Peters will be presenting with her, and she is a faculty member with the Swine group and the Veterinary Diagnostic Lab, and the principal investigator of the Mycoplasma Research Laboratory, and director of the Swine Disease Eradication Center at the University of Minnesota. Dr. Peters leads research efforts on diagnostic, epidemiology, and control of Mycoplasma infections in pigs and other animal species. And her main research is on applied tools for disease elimination. So with that, we'll let Haley and Maria start.
Thank you for sticking around for the last presentation of the last session of the conference. I really appreciate it. Just going quickly into this presentation. This is a study Haley and I are in this tech team and will be presenting, but this is the effort of many collaborators. This is a very large study that we have been working on. So by any means, this is not just the work that we are doing. Well, just to make sure that everybody's on the same page, when we talk about mycoplasma, usually in swine we say mycoplasma, we are referring to Mycoplasma hyosynoviae, right? And the one that we had two presentations about and causes respiratory diseases in pigs. But there are other mycoplasmas that are infectious to pigs and cause disease. And one of them is Mycoplasma hyosynoviae, mainly in nursery pigs in that age. But also Mycoplasma hyosynoviae is an important agent causing disease in pigs. Mainly, this is evident in arthritis, in lameness in those animals. So, apologies in advance if I mix up the names. Sometimes it happens, but we'll be talking about Mycoplasma hyosynoviae here. So, but let's start from the very beginning, saying, is this an emerging pathogen? Or is this an emerging disease caused by Mycoplasma hyosynoviae? And I want to say this because this is what we hear a lot in recent years. We hear about these issues being present now more than they were before. And one thing that I want to say is that, yeah, it is a pathogenic agent in pigs. It causes disease. There are models, and it has been documented that, with an infection model, you can reproduce the disease. It's not very clear cut, but this happens. So it's recognized as a pathogen, but it's also a commensal in pigs. And more recently, and I would say in the last decade or so, we have had an increased report on the detection of this agent. And honestly, I battled myself with how to call this agent, and it's hard for me to have clear in my mind. Is this because there is increased awareness of the problem? That could be something. Is it because the clinical presentation is different now than it was in the past, and that's why we see it more now? Or is it because the diagnostic capabilities have improved? Like 15 years ago, we didn't have a PCR test that we were running for Mycoplasma hyosynoviae on a regular basis. So now we're detecting it more. We have better tools. Is that part of the problem? So I don't have an answer for all that, and this is something just to keep it in your thoughts here. But we know that it does cause clinical disease. Okay, in many instances we see animals that have this arthritis, and we see those swollen joints, and this can be very evident in the field. In some cases, can be acute, can be more than one leg that is involved, more than one joint, I should say. And we see that those animals have a reduction on weight and well, one would say appetite, but in reality is that there is pain, the animal is in pain, cannot get to the water or the feeder, and that's why there is a weight loss. Recovery can happen in some instances, and in some other cases we see that the stiffness remains, and then it can be complicated with osteoporosis as well. But what does it represent to the industry? And we have we know and recognize that arthritis and lameness are a big issue for the industry. And these numbers are, if you see the ranges of, how this affects the animal welfare or the production cost, you see that the range is very large, like from 2 to 30% or $2 to $23. There are few reports out there, and there are many confounding factors in all of them, and we see that this varies a lot. However, we see that the main issues are in feed efficiency and treatment costs that we see that are affecting the production cost, but this is a significant cause of lameness. And when we think about who is affected or which animals are affected by Mycoplasma hyosynoviae, we think about the growing pigs, right? But also in the gills that are coming into the sow farm that are a replacement, those pre-breeding gills, this is a problem as well. This is the main cause of culling. Lameness and arthritis, this is not a simple issue. This is very complex, and there are many different factors that can play a role in the development of disease. There are factors that are infectious in nature and some others that are not. So this is not an easy thing to think about. But at the end of the day, animals need to be relieved from the pain, and antibiotic treatment is used in the field for this. Okay. With all this in mind, and with all the conversations that we have with producers and veterinarians, our overall goal in the laboratory is to characterize how the pig responds to Mycoplasma hyosynoviae, so we can design and help design better strategies for the prevention and control of this agent. Ideally, we want to decrease the use of antibiotics and improve the overall welfare of the animals. So, just put in a different way, we want to be able to get to this red spot, develop the prevention and control strategies. But to be able to do that, we need to know the agent, and we need to know how the host responds. So, we look into the literature and try to learn more about this. And I like explaining things with cartoons. When I think about the epidemiology of this agent, we know that there is transmission from the sow to the piglet. And this first part here of the line, this is when the colonization, we think it happens, right? But there is no clinical presentation per se. And clinical presentation would start at the beginning of the growth finishing period, mainly, and some signs can be seen later on as well. But this is how we think it's the epidemiology of this agent. But there is a big issue here. This is where we're at with Mycoplasma hyosynoviae. This is an agent that was identified for the first time in 1970, and 86 papers only in the last 53 years have been written or published, right, about this agent. Okay, so we're talking about less than 2 papers a year. So this is the pace in which we are advancing what we know about this agent. And just to put it in context, right, if we compare to Mycoplasma pneumoniae, and I always complain, oh, there is not enough information and all this. Well, there is over 1,000 papers for that agent. And then for PRRS virus, this is a greater number. So just for you to have an idea how little research is being done and how little is information is out there. But Haley will talk to you about her project, right? And this, in the first part of her project, she started looking into serological profiles. So we went to the literature and looked at what is out there for serological information on serology for Mycoplasma hyosynoviae, and there are 2 studies that we could identify and get to. And one is from 1999. Both studies are from Europe, small farms, small group of animals. In this one, they looked at 3 clinically affected herds, and we see how the antibodies were detected there are different ages of pigs that are tested, and they detected antibodies at birth and the first weeks of age. We see those antibodies going down, and in some cases we see here the tonsillar carriage of Mycoplasma hyosynoviae, and we also see in some cases they did isolation of the agent, and clinical presentation is included here. So this is the pattern, but this is only a few pigs, like 100 pigs in 3 clinically affected herds in Europe. The other study, also from Europe, from 2005, they looked at sows as well, And if you can see here in the black color, these are different herds, 8 different herds. And in some of them, most of them, we see that the sows had a significant, detectable antibodies for the agent, but in the pigs, we see that those patterns differ. There is no data that we know of for this agent on on the United States or in the North American production systems. And with all that, thinking about all that and other ideas that Haley will tell you about, she went on to this study. That is a very large study, you will hear from her, looking at pigs from the sow farm and while they were on the sow and going into the nursery sites and then onto the finishers as well. And she will walk you through the entire process.
Can you guys hear me okay? I'll show you the microphone. Good? Okay, so as Maria mentioned, this project is a very large project and we have it broken down into 2 different parts. So I'll be referring to them as phase 1 and phase 2. As Maria said, our first phase included some antibody profiling within some of these herds. And then our phase 2 actually looked at a different treatment option utilizing a vaccine. As she mentioned, antibiotics are currently used. We wanted to look at our different opportunities that we had. But first we have to start with our phase 1 and look at some antibody profiling in order to get to our phase 2 and really decide on those vaccination timings. So the first aim of this study was to determine the natural antibody profile of Mycoplasma hyosynoviae in a clinically and non-clinically affected swine herd with under the same system. So 2 of these 9,000 head sow farms were enrolled. One had clinical lameness downstream, and in comparison, another one did not, being referred to as the non-clinical herd. Both of these are farrow-to-wean operations. They both had their own on-site GDUs. They were both located in the Midwest, but not within the same state. So what we did is we went into both of these farms and we collected serum and colostrum samples cross-sectionally from numerous age groups. We looked at sows in different stages of production, piglets starting from newborn all the way to the finishing stage. We also collected those colostrum samples, and we also looked at those replacement gilts on those on-site GDUs as well. So this sample size calculation was based on our 4 different stratas, which were those different sows in different stages of productions. We were trying to detect a minimum prevalence difference between 4 and 7%, and that's where our 400 came from. So in a similar approach, we used that going into our sample size, looking at those piglets and replacement gilts as well. So into our clinical herd, we ended up with 18 different sampling groups. Again, we targeted those dams in different stages of production, at service, at mid-gestation, at farrowing, and at weaning. Then we went into those GDUs to look at those replacement gilts, increments of 5 weeks of age, starting at 5 weeks of age up to 30 weeks of age. We sampled some newborn and weaning piglets. We collected 27 colostrum samples. And then we went into those downstream sites, into the nursery and finishing sites, which we collected at 7, 9, 10, 12, and 19 weeks of age, for a total of 1,805 samples, which also included those 27 colostrum samples. And then again, we went into this non-clinical herd. As you can see, our sample size is a little lower, just due to the traveling in between and sample size prior to this. We try to replicate as best as we can, but still again ended up with a smaller sample size. We still targeted those similar sampling groups at similar ages, being those dams all in the same production stages, at service, at mid-gestation, at farrowing, and at weaning. We went back in that GDU, found replacement gilts at 10, 15, 20, 25, and 30 weeks of age. Then we looked at those newborn and weaning piglets. We recorded 23 colostrum samples, and then we tried to fill those age gaps we didn't get in the clinical herd. So we got nursery pigs at 5, 8, those finishing pigs at 13, 16, and 20 weeks of age, with a total of 677 samples. So all of these samples were then tested utilizing an indirect ELISA assay specific for Mycoplasma hyosynoviae IgG detection. And this cutoff value was greater than or equal to 0.6. And anything greater than or equal to is considered positive, anything below that was considered negative. All these results that we're going to look at now were only analyzed descriptively up to this point. I haven't had time to run statistical analysis, but I'm really excited to do that here in the near future. So first, looking at our clinical herd, again, these are Mycoplasma hyosynoviae specific IgG antibodies per sampling group. So what we did is we found the percent positive per sampling group, which you can see on our y-axis. And then on our x here, we have all our different stages of those sampling groups. I have them ordered in different stages of productions, starting with the sows and then increasing as age and weeks increases in those nursery, replacement, and finishing pigs. Those bright blue are our replacement gilts. I just wanted, again, to kind of fill those age gaps looking at these results. And then our nursery finishing pigs are in the lighter blue. The dams are all in the navy and our colostrums in black. So if we see here, we can see that the sows have a very high percent positive per sampling group, which again, we saw with Maria's information she presented that those sows in that previous literature also had very high percent positives. In our newborn piglets, we see an 86% positive. This is a small limitation we experienced. We're not completely sure all of those newborn piglets had suckled colostrum to receive those antibodies. So we accounted for that in moving into our non-clinical herd, but we kind of would have hypothesized that to be a higher percent. But moving into the weaning pigs, again at 92% positive, and then we can see a decline in those percent IgG levels as that age and weeks increases, which just with conversations with these veterinarians and producers within this system, we're really starting to see that lameness occur at this lowest percent of those IgG antibodies. So this is also just representing the sample to positive values on our y-axis per individual pig that we sampled. Not a lot of variation between each sampling group. We see those outliers here, but definitely expected within any sampling event. So moving into our non-clinical herd, again, we have it set up the same with percent of pigs positive per sampling group. This is ordered the same. There are a little bit of differences in those age and weeks, so just keep that in mind. However, it's very interesting to see that all of these sows really remained high percent positive. 100% colostrum, yes, this is a much smaller sample size, but it just really represents and compares to that clinical herd as well. However, as we see those antibodies decline again as those age and weeks increase, in this herd specifically, we see those antibodies increase here around 16 weeks of age. So is there possible protection utilizing those antibodies is what we want to investigate further. And this again is just those sample to positive values within the non-clinical herd. Again, a few outliers, not a lot of variation, but just really interesting to look at here. This is a graph, there's a lot going on, a lot of colors. However, I really want to show you a side-by-side view, comparing that non-clinical herd with the clinical herd, the non-clinical being in green and the clinical being in navy. And all of these are just side-by-side within that same sampling group and same sampling time. And the only difference that we see here is, again, in that non-clinical herd, those IgG antibodies really increasing per sampling group. And this is just one more illustration showing that those specific sample to positive values, again, within the clinical herd here on the left, and then the non-clinical herd here on the right. So utilizing that information from that phase 1, especially where those antibodies really tended to decrease, we went into our phase 2 looking at the optimal vaccination timing utilizing an autogenous vaccine specific for Mycoplasma hyosynoviae. So this is our overall experimental design. This is just a broad overview. We're going to break it down a little bit. But we started with some sow vaccinations, and then we have our different treatment groups within those piglets here. All these dashes are weeks of age. So we've been following these pigs prior to even being farrowing, and we're going to follow them all the way through life into market. We'll be doing lameness scoring, sampling, and weighing, which I'll break down a little bit further. So as I said, we kind of started with some sow vaccinations. So all these sows were randomly divided into 2 different treatment groups, being either unvaccinated or vaccinated. If the sows were vaccinated, they received a vaccine at 5 weeks pre-farrowing and a booster at 3 weeks pre-farrowing. Then within every one of their litters, there was 12 piglets randomly enrolled, and then they were randomly assigned to 4 different treatment groups. Those 4 different treatment groups included a control group, which none of those piglets received any vaccine. The second one being vaccinated at 1 and 3 weeks of age, which really replicates industry practices being at processing or around weaning, and then around weaning. Our third treatment group being vaccinated at 3 and 5 weeks of age, again, kind of around that weaning time point and then 2 weeks post-placement in the nursery. And then our fourth treatment group, we decided to vaccinate around 8 and 10 weeks of age, just referring back to those phase 1 results where those antibodies really tended to decrease. So there was 8 different treatment groups because, again, including those sow vaccinations. So our treatment group A here was just the control, no sows or piglets vaccinated. Our treatment groups B through D, again, those sows were not vaccinated. However, those piglets received either 2 doses in the farrowing room, 1 dose in the farrowing room, 1 in the nursery site, or both vaccines in the nursery site. And then our treatment groups E through H, again, the same replicate as we saw in B through D. However, those sows also received 2 vaccines as well. So starting from the beginning of piglet enrollment, what we did is we went in, we randomly enrolled those 12 piglets. All of these piglets received a color RFID tag. They were then individually weighed, individually sexed into our system. They were put into those random treatment groups. And then they also received ear notches just for a second identification in case we were to lose that ear tag. So looking at that sample size from phase 1, we saw a very high sample size we had to collect. Similar with this approach in phase 2. We had to think of almost worst case scenario for prevalence rate, just based on the lack of literature. So we actually ended up enrolling 11,463 piglets, which came from 1,186 litters. So some outcomes that we will be looking at and that we actually have started in the field is that lameness scoring, which has been used in previous literature. We've been collecting weights at birth, as I mentioned, individual weights again at weaning. We'll be taking a subsets of weights at end of nursery and then end of finishing, just for individual performance. Individual antibiotic treatment has also been recorded from birth. Individual mortality. We are taking tonsil swabs for detection by real-time PCR, and then also again taking more serum samples for Mycoplasma hyosynoviae antibodies, utilizing that ELISA assay as well. Some limitations that we have faced just between both phases, phase 1 and phase 2. As Maria mentioned, this is a commensal microorganism, so just because we're seeing those IgG antibodies does not technically mean we're going to see that clinical lameness or any infection or colonization. However, this is one system being evaluated, just keep that in mind. We're really excited to move into another system within the next few months to try to look at different clinical and non-clinical sites within a different production system. In phase 1, we did not collect those sow IDs that we had from the antibody profiling. We accounted for all these parity of sow samples in the phase 2. However, that really would have been great to look at parity distribution in phase 1. So where we're at now, we're currently in the barn still weighing, vaccinating. We've been taking tonsil and serum samples. All of these pigs are now in their finisher and or wean to finish site. There's 9 different sites distributed across Iowa, Minnesota, and South Dakota.
Thank you, Haley, for walking us through that. And I wanted to make a summary of the results, just to say in general what Haley saw in that antibody profile. Antibody profile. And basically, it's a high percentage of them that have a high level of circulating antibodies for Mycoplasma hyosynoviae. Those maternal antibodies are transferred from the sow to the piglet, and the decay appears several weeks post-weaning age. Those low levels of antibodies coincided with the onset of clinical signs in the clinically affected herd. However, we saw a similar pattern in the non-clinically affected herd, and those antibody levels started to increase at 15 weeks of age. So with all this, it's really hard at this point, and we don't have all the results of the study. This is just ongoing, and your pigs are about 10 weeks of age right now. So you will be hearing more in the future about this. But bottom line, there is a lot to be learned about this agent. We don't really have a lot of information, but we need to know more about the epidemiology and the immune response to this agent to be able to think differently about the control and prevention of it. Given that it is a commensal microorganism, the serological profiles are really challenging to interpret. Is this the result of exposure or infection per se? Just the colonization is, what is it that we are seeing with those results? It's really difficult, but definitely more research is needed. And in the interest of time, I'll just jump here.
Yeah, and just being such a large project, I could have 20 slides of everyone's names, but I really want to reach out to all of those research teams, those graduate students, veterinarians. Like, this has been so much fun and such an honor to work on this project, and I really appreciate all the support in the barns, out of the barns. So thank you very much for all of that. And with that, we can take any questions if there's time.
Maria, it's exciting to see very practical work on a pathogen that there's so few papers on, right? So any questions from the audience? We probably have about 5 minutes before the wrap-up session.
Hello, good morning, and congratulations for the talk. The question is, did you perform an internal validation of the cutoff for this ELISA? It's quite high. I know that's in-house, but do you use reference serum against another Mycoplasma to check this cutoff?
Yeah, I can, yeah. So this ELISA assay is actually specific. Jimenez L'Oreal from Iowa State University. So all of these samples were submitted to there. But within the paper, you can see that they looked at all those different cutoffs. They saw that this was the highest 100% specificity and then 93.7% sensitivity. So they looked at all of that within that paper. But yeah, thank you.
Thank you for the answer. Another question is, did you perform some potency tests of this autogenous vaccine to know the profile or expected profile in a controlled way?
Well, this is a vaccine, and I don't know if we can have anyone from the vaccine manufacturers here giving more information about it. We did not manufacture the vaccine. It's coming from Newport Laboratories. It's a vaccine of a company. So we did not do that internally.
I guess I have a question related to my thought process, so I might lay that out, throw it out to you guys, and then you can tell me how foolish I am. But my question is the difference between the clinical and non-clinical. The non-clinical farm having higher antibodies in the sow farms. My speculation would be potentially, is there a difference in like the acclimation process or something like that? Are you getting better control because of earlier exposures, things like that, that would allow for a more consistent sow status, leading to more uniform protection of the piglets? In your observations, do you see anything in the difference from a management standpoint, gilts and or sows that you think would lead to that difference in the antibody profile of the mature sows?
Yeah, no, great question. And it's within the same system, so again, there's very similar management practices. Again, that's going to vary between even those two sow farms. So I do think that could play a role. I really want to further investigate environmental factors. It's something we've really talked about. Because again, you're seeing those, antibodies increase, but no clinical lameness within that non-clinical herd. So it's very puzzling to really see that acclimation period. Just for observations, not much difference, no.
Thank you.
And I would say, Brenda, that that's the route we're going, in our thoughts. So our hypotheses are going there. Are we doing something different with the gills or the sows for the farm? Is that why we're seeing different things? But Haley said it very well, and these are actually sister farms. known as that within the system, so they're very close in the way in which they manage their farms.
It can be the possibility different strain in one farm from the other if you do the sequenciation, for instance?
That's a very interesting question, and I am not aware of any sequencing that is being done for hyosynoviae, but definitely, I mean, like we can try to locate some samples into each one of the farms and then bank them for the future when there is a method that we can look into. But definitely, that could be an explanation as well, and we wouldn't know that. Not at this point, we don't know it.
Because if one farm there is problem and in the other there is no problem, with the antibodies it's more or less the same, and the management is more or less the same, probably it's not the same the strain of the bacteria.
Yep, we have to think, you know, you're totally right on that, but we have to think that there could be different, different things going on with the pig itself, right, you know, how it responds, with the bug, and also in the environment. So there are, you know, different aspects that we need to look into. But honestly, there is very little information that we can go to, and there is not a standard right now for sequencing of Mycoplasma hyosynoviae that we know of.
Okay, well, thank you, Maria and Haley. And